Welcome to the mill project number 1 SolidWorks tutorial. In this segment I'm going to show you how to model this mill project number 1's solid part. The first step is to look at the engineering drawing and familiarize yourself with the different features and views from the model. Next we'll open up SolidWorks and we're going to start with the part environment. So press OK and this will open up the SolidWorks part environment. Now remember, we have to be thinking about where we're going to model this part when we first start off. We have the three mutually perpendicular planes, the front, the top, and the right. And we have to determine where we want to model this front view off of. So what we're going to do is we're going to select the front plane and draw a 4 by 1.875 rectangle on the front plane and extrude it back. So to do this, we're going to use the Features menu up here and the Extrude tool. So we're going to click on Extrude. We're then going to select the front plane. From this point, we need to draw a rectangle. All of our sketch tools become active up here once we select the Extrude feature and select the plane. Now, this sketch, if we go back to the drawing, is a simple rectangle. And I'm going to lock the corner point of the rectangle in the bottom left corner. It's always a good idea to lock your geometry into the origin at some point. So I'm going to select the rectangle tool and drag out a rectangle that's very similar to the size of the rectangle in our drawing. Then, it does not have a size dimension associated with it yet. It actually does. 1.0 inches. However, we want to lock that in using Smart Dimension or define it using Smart Dimension. So I click on my Dimension tool up in this top left corner, Smart Dimension, and I click the line, the vertical line, and drag outwards and click my mouse button again. This dimension displays 1.089 inches. To change it, I simply type in the dimension I would like to obtain, such as 1.875. Enter. What that does is it goes ahead and it changes the dimension and it scales the rest of the sketch based off that dimension. Next, we need to go ahead and specify the width. So we drag a dimension up and we go ahead and we type in 4.00 check mark. So far, we've created a 1.875 by 4.000 inch rectangle. That's all we need for this extrusion. So I'm going to go ahead and exit the sketch by clicking the Exit Sketch button at the top left corner. What that does is it brings it out into the 3D environment and allows me to select a thickness for my parametric sketch. Going back to the drawing, I look at the overall thickness of 0.48. I'm going to extrude it out to this thickness and use the cutout tool in order to remove the material around the outside perimeter. So therefore, when I go back to the SolidWorks model, I'm going to key in the thickness of 0.48 inches and hit the check mark. This is the first feature we've created for the mill project number 1 model. In fact, if we wanted it to make sense, we could right-click over here in the Feature Manager and go to Feature Properties and write Body Extrude. What that does is it allows us to name our features and keep track of them instead of using the default SolidWorks names. Next, we're going to go ahead and round the corners real quick using the Fillet feature up here in the Features toolbar. Referring back to my drawing, I see the radii for the corners of this part are 4 by 0.25. That means there's 1, 2, 3, 4 radii that need to be a 1/4 inch. Moving back to my SolidWorks model, I select Fillet, which creates a radius on the corner of a part, and I key in the radius value of 0.25. Next, the items that need to be filleted are the edges. So I simply move around and click on the edges of the workpiece. If you don't see the preview, notice over here in the ribbon bar, or in the model tree bar, we have partial preview, no preview, or full preview. I like full preview because it kind of gives you an idea of what the fillets are going to look like on your part. Once you have the size and the correct edges selected, hit the check mark and the fillets are created on the model. Now we can go over to the fillet, right click, hit feature properties, and right corner round. This just shows you that you can name any of your features. Just remember, it's parametric feature-based modeling. The parametric part is the 2D sketches that are driven by dimensions that get extruded out to a 3D component. Now, we're going to go ahead and analyze our drawing to see what needs to be performed next. Looking at the drawing, we're going to go ahead and create this cutout around the outside of the front face. To do that, we're going to use some of the more advanced sketch tools in our cutout feature. So moving back to SolidWorks, looking at the model, remember we can always hit spacebar to bring up the orientation toolbar, and then isometric to orient ourselves with our model. In order to create a cutout on the front face, we're going to use our features tool, the extruded cut. So I click on extruded cut. Next, I have to select the plane in which to cut out on. So I'm going to select the front face of the model. Now, in order to orient the view normal to my face, I hit spacebar and the normal to button. This makes the 2D sketch become normal to my view. At this point, I'm going to use the Convert Entities button, and I'm going to select the outside edges of the part. What this does is it converts the outside edges from the last feature and places them as sketch entities on this feature. So when I hit the check bar, I now have an outside profile driven by the previous feature's geometry. At this point, I'm going to hit Offset Entities, and I'm going to make my base geometry that I select construction. What that means is construction geometry is used to build model geometry. It's not used to create a feature off of. So it's used to basically reference other pieces of sketch geometry that need to be used to build a model. Therefore, I'm now going to offset everything 1/8 of an inch around my part towards the inside, like so. What that did is it made outside construction lines, which won't be used to drive the feature, and it made that 1/8 inch offset around the inside of the model there. So moving back to my drawing, you'll see I just created this outside perimeter. Now I have to create this circular cutout in my model. To do that, I simply go back to my SolidWorks model, and that's a circle. So I select my circle tool, drag it over, place a circle, and then I use Smart Dimension to select the tangent edge of the circle up to, not there, I use Smart Dimension, pick the tangent edge to the edge of my part. Then looking at the drawing, moving back, we have a 0.25 distance from the bottom edge to where the center of this 1-inch diameter circle will be going. So moving back to my SolidWorks model, if I type in 0.25, it's going to be my distance. I'm going to go ahead and go 1-inch diameter, which is a 1/2 inch radius. Then last but not least, I need to find the distance in the x-axis. So moving back over to my model, I see that I've got 3.75 to the center of that radius. So going back to SolidWorks, we smart dimension from that edge to the center. We type in 3.75. Now, I'm going to introduce you to the trim tool. The trim tool trims overlapping entities. It's up here as one of our sketch tools. So when I select trim entities, I like to trim to closest. What that means is every piece of geometry I click on, it goes ahead and it trims it away to the nearest or the next closest line. So you'll see I was able to trim away the circular cutout as you see right here in the front view. Last but not least is the fillet tool. We have to add fillets within the sketch. There's two ways to fillet. You could fillet a feature like we did previously, or you could fillet a sketch entity with the sketch fillet tool. By clicking on the sketch fillet tool, you're able to enter the fillet parameters, such as 1/8 of an inch, and then click on the edge you wish to fillet and hit your check mark. At this point, we have an inside profile here that we wish to keep. We wish to remove everything outside that profile. Therefore, we have to draw a closed profile within a closed profile. I can do so by dragging a rectangle around the outside of the sketch, and this is going to allow me to cut the inside of my sketch right here. So when I hit Exit Sketch, you're going to see that when I select my distance, I'm really only cutting what's the profile in between the two closed profiles here. How far down, you say? We need our engineering drawing for that. So back to the engineering drawing, we look over here and we see the overall part's thickness is 0.48, but we want to cut down 0.2 of an inch with this cutout. So going back to the SolidWorks model, you'll see we're going to cut blind, which is a certain distance down, and that's going to be at 0.2 of an inch. So when I hit my check mark, it cuts down that distance. Now we have our major two body features here. We have the body extrude and then the cut extrude. At this point, I'd really recommend saving your model and saving often. You never know when the computer is going to crash. So we'll go File, Save As, Mill Project Number 1, Giorgio. Go ahead and save yours as your last name. At this point, I'm going to hit the space bar and go back to an isometric view and look back at the drawing to see what's next. Looking at the drawing, we're going to go ahead and create the cutout for this pocket right here. So to do that, we go back to SolidWorks and we're going to create an extruded cut feature. We're going to do that on this top plane of the model. And in order to get the cutout or the view normal to our face, we hit spacebar and normal too. Now we need to go back to our drawing and look at our dimensions. Looking at the pocket, it's 1.1875 inches wide and it's 1.375 inches tall. So I'm going to go ahead and create a rectangle that size that is 1/8 of an inch off each edge right there. So to do that, we'll go ahead, go back to SolidWorks, and use our rectangle tool. I drag out a rectangle. Now I'm going to press Escape to end the rectangle tool and hit Smart Dimension. I'm going to click on the top edge, drag it up, and this was the 1.1875 measurement. And that edge was from here to here 1/8 of an inch, so 0.125. Now, I'm going to go ahead and grab this line with my Smart Dimension tool and drag outwards. I click my mouse button one more time to place the dimension. Then I type in 1.375, I believe. Excellent. Last but not least, to fully constrain this sketch and make all the lines black, notice these two are still blue, I have to dimension from here to here. And that value is going to be 0.125. That fully constrains this sketch. I have a size for my rectangle and a location for my rectangle, fully constraining it. Hence, all the sketch geometry is now black. I press Escape in order to end my Smart Dimension tool, and I'm going to go back to my drawing and look at my fillet size. Looking at this callout, there's 4 by 0.325. So I'm going to go back to my model and select Sketch Fillet. I'm going to key in 0.325 and click on the edges. When I hit check mark, it creates the fillets, and at this point I'm ready to exit my sketch. Now, I don't remember how deep to extrude, but I can always go back to my drawing and look, and I see that I'm 1/8 of an inch deep for this cutout, thanks to my section views. So I'm going to go ahead and key in 0.125 for my cutout depth, and I'm going to hit check mark. That created my cutout for my pocket. I'm going to go back and rename my features so they make sense. I can simply go back to my first cutout and right click on it and go to Feature Properties and do Outside Profile Cut and press OK. I can right click on this one and go to Feature Properties and write Pocket Cutout. Press OK. Now in this assignment, we don't expect you to cut out the Cal Poly and the manufacturing engineering logo, but I'll go ahead and place the logos as sketches up on PolyLearn in case you're interested in trying it out. This video will not cover that though. You'll have to stop by office hours. Now that I have my major features established, I'm going to go back to the drawing and see what's next. Looking at the drawing, I have a circular, semicircular cutout in the kind of the front plane there, or I guess it would be the top there, section view, coming down from the top. Or I could create the holes. I'm going to go through and create this cutout first, then we'll go through and learn how the hole wizard works in order to create the last couple features. So, in order to create this radial cutout here, I'm going to look at this. This is 1.56. It ends up being 2.5. You'll see it's rounded up because we didn't need to go to a 1/2 thou for the precision. However, we're going to go ahead and do that in this model. Now, looking at the location, we've got the location and we've got the size. Actually, looking at this radius right here, and looking at the radii right here, unless specified, they're 1/8 of an inch. So we have to assume, since this one has not been specified, it's 1/8 of an inch in size. So moving back to our drawing, I press space bar, and I look at my top view. This is where I want to create the cutout. So when I select Extruded Cut, I pick the cutout surface, right there. Then I pick a circle, and I simply place a circle on the edge of my part, and I size it 0.25 in diameter, which gives me 0.125 radius. Now last but not least, I'm going to click on the circle, and then the edge from where it's dimensioned. If we look, it's the edge of the cutout, 1.5625. So if I go from that edge and drag down 1.5625, that has been fully defined because it knows where it's located in the y-axis because it's connected to that edge. It's located in the X 1.5625, and then the size is 0.25 in diameter. So when I hit Exit Sketch, I move over here, and because it goes all the way through, I don't have to worry about a blind direction. I can select Through All and hit the check mark. What that does is it creates the cutout through the top of my part. It goes from top down through the front face. And next, hit Save. At this point, we're going to name that cutout. We're going to right-click, go to Feature Properties, and call it Circular Cutout. Press OK. Now what's left are chamfers and holes. We'll save the chamfers for last to make sure we don't cut ourselves on any sharp edges, virtually. And we'll move on to the hole wizard. Notice the hole wizard is how you make simple holes. So looking at our drawing, we have a simple hole right here that goes through. We have a blind hole that doesn't go all the way through, goes down a certain depth. We have a counterbore hole, a countersunk hole, and a threaded hole. The hole wizard will make all 5 of these types of holes. Moving back to SolidWorks, we're going to pick the simple hole first. So when we select Hole Wizard, notice we have more than 5 different types of holes here. We're going to worry about the 5 different types at the beginning here. So we have a counterbore, a countersunk or countersink. We have a hole, that's a simple hole. We have a threaded hole made with a tap, hence they call it straight tap. And then we have a tapered tap. So if we had a pipe thread, we're going to go ahead and cover the counterbore, countersink, hole, and straight tap in this class. Everything we do is going to be in the ANSI inch standard, so we're going to keep it there. And we're really going to not worry about all the sizes here. We're going to create our own custom sizes. But realize SolidWorks takes a lot of the mechanical engineering table kind of referencing out of the equation here for some of the engineers, where they'll allow you to pick a screw size, and then it builds the hole that's supposed to be kind of that's in reference to that screw size. But what we're going to do is we're going to hit custom sizing for everything and build it based off the custom sizing, so we know how that actually works. Now, what we're going to do is we're going to look at the simple through hole first. That's very simple with custom sizing because you just put in your diameter right down here. So for this hole, this simple through hole, it's 0.201 in diameter. We're going to use a number 7 drill, and it's going to go through all. So one thing we don't want is a near side countersink. We will worry about the chamfer later on with the different features. So we're going to unclick the near side countersink. So to make a simple hole, we are going to pick hole. We're going to hit show custom sizing and put the diameter of the hole in. This one goes through all. And in order to select, or in order to place the hole, we go to Positions tab up here. Now, we go ahead and we click on the plane where we wish to create the hole, and we simply press spacebar, normal 2, and place the hole. Now, in order to locate it, we've already given it size in the Type tab. The position locates it. We're going to use Smart Dimension to dimension from the center to the edge. And it ends up being 0.25. Next, we're going to dimension. If we go back to the drawing, we just went from there to there. We're going to go from there to there, another 0.25. So moving on up, we go from here to the center, 0.25. That fully defines where that hole is located, hence the center point turned black. So when I hit my check mark, we just made a through hole through the part. Now if I go back, notice it said it was a number 97. We could go back, we could go to edit feature and build it the appropriate way by giving it it's actually a number 7 drill bit. Notice they give you the sizes of the holes based off your drill bit size. So we don't even need to hit custom sizing there. You could, it'll show you that it's a 201. And we hit check mark. At this point you should save your model. Remember, save after every feature you create. And press spacebar, isometric, and save. The next hole we're going to create is a blind hole. A blind hole does not go all the way through the part. So if you look right here, we have this 0.27 diameter and it goes 0.38 depth. So that 0.27 was made with our F drill. So we're going to make sure we use an F drill to size the hole and make sure we go 0.38 depth. So moving back to SolidWorks, we select Hole Wizard. We make sure we have a hole selected. It's going to be an F-size drill bit. If you hit Show Custom Sizing, it shows you the 0.257. And this one's going to be blind at 0.38 depth. So we selected the size of the hole on this tab. And remember, we select the location with the Position tab. So when I hit Position, I pick the top surface where the hole is going to go. I press spacebar, normal 2, and then I place the hole close to where I want to place it. Now in order to give the location dimensional values, I select Smart Dimension and click the center point to the top edge of the hole. Moving over, I see that I've got, over on my drawing, I've got the height measured from the bottom. So actually I need to go back, press X, and at any time to delete a dimension, you can click on it, hit delete. So I'm going to reselect Smart Dimension, go from the bottom edge up, drag over, type in 1.25. Now, back to my drawing, I see that it's 2.125 from the left edge. So I go from this edge to that point, 2.125. At this point, I've now fully located it and sized my feature, so I'll hit check mark to end it. You'll see I've got a number 7 and an F hole. This hole was a blind hole, and looking at the blind hole, you can see that we have a conical point at the bottom. It's imperative that you use the Hole Wizard to create any hole that's blind, because you need to go ahead and simulate the amount of material that's missing from that drill bit's point. Okay. Now we're going to learn how to create a counterbore hole. So going back to our drawing, we see that this is our counterbore hole. It's 2.75 from the edge, 1.25 from the bottom, and the counterbore's diameter is 0.44, 0.25 deep. The through hole value always comes first in your hole callout. So it's 0.27, so it's an F-size through hole. The counterbore is 0.44 in diameter, 0.25 deep. So you'll see right here's our counterbore hole in this section view up here. So moving back to SolidWorks, we're going to select Hole Wizard. We're going to pick counterbore hole. And really this is for a 1/4-20 socket head cap screw. So if we went socket head cap screw, quarter, and I said show custom sizing, you'll see it's very close to what we've got. But what we're going to end up doing is we're going to modify the counterbore values in order to set up the appropriate size feature. So to do that, we see that we have a 0.257 diameter hole. Going back to the drawing, it's actually 0.4375 is correct. If we look at our drawing, it was rounded up to 0.44, so we'll be fine with that. The depth is 0.25, so that was excellent. And then The bottom of the drill bit would be 118 degrees because we're using aluminum and basically chisel point or chisel tip drill bits. Now, this one's actually not going to have an end condition. It's going to go through all. Therefore, the drill point angle went away because the hole goes all the way through the part. There's not actually going to be a point angle at the end. So let's review. Counterbore size is going to be for a 1/4 inch socket head cap screw. We have to show custom sizing because we actually changed the through holes value a little bit of 2.257. Now the counterbore's diameter is 0.44 on the drawing or 0.4375, 1/4 inch depth, and the hole goes through all the F-size drill. So at this point we hit position. We select the top face where the counterbore hole goes. We press spacebar and normal 2 to get it normal to our face. And now we'll go ahead and place the hole very close to where it's supposed to go. We're going to use our Smart Dimension tool up in the top corner to dimension from the center point to the bottom of the part. Click our mouse button and key in 1.25 inches. Then we go from the left edge over to the center of our part, and it's 2.75. When I hit check mark and check mark, it creates our counterbored hole. I then press spacebar isometric to check out our model and hit save. The next hole we're going to create is a countersunk hole. The countersunk holes you made with the hole wizard. It's going to be the second one over. When I hit that, it says I've got custom sizing values. I'm going to reset the custom sizing values. Now, for this countersunk hole, I go back to my drawing and I see that my diameter is a 0.266. We're going to actually end up making it with the same drill. This is a mistake on the drawing. The same drill that this one was made with. So therefore, what we're going to do is we're going to create it with an F-size drill. And where the countersink's diameter is going to be 0.5 in diameter by 82 degrees. So we're going to move back over here and we're going to build our countersink. So it's 82 degrees. The countersink is going back here, so it's 82 by 0.5 in diameter. So 0.5 in diameter, and we have a 0.257 drill. All right. At this point, we're going to go through all. We're going to hit position. Click on the face where the countersink goes. You press space bar and normal 2 and place your countersunk hole. Now in order to dimension it and locate it, we hit Smart Dimension. We go from the bottom edge to the center of the countersink. Type in 1.25. Then we go looking at the drawing. We're at 3.375 over. So you go from that edge to the center of the countersink, 3.375. That fully positions the countersunk hole. So when I hit check mark and check mark, we have our fourth hole placed in the part. Last but not least is our 1/4 20 threaded hole. So looking at the drawing, we have a 1/4 20 UNC hole. There's no depth call out, so we remember when there's no depth call out, it's a through hole. If it's not through, put a depth call out on it. So we're going to move back to SolidWorks and use that hole wizard to create a straight tapped hole. Remember, the tapped hole or the tap makes a threaded hole. Hence, they call it a straight tap hole. So if we move over to our SolidWorks straight tap hole, Here, it's going to be an ANSI thread. All the standard thread sizes are in there, coarse and fine. So we have a 1/4 20, which is a coarse thread. You're going to see it gives you the tap drill size. It's a through-all thread. We don't want a near side countersink though. It goes ahead and puts a huge chamfer in it for you automatically. At this point, our 1/4 20 hole will be created in a specific position on this face. To do that, we hit our space bar on our normal 2 button. We place it down there. We go to our drawing, and we see that we're a 1/2 inch from the bottom edge and 2.5 from the left edge. So Smart Dimension will allow us to dimension from the center of the part, or the hole, to the edge. And that's going to be 0.50. And from here, from the left edge to the center of the part, at 2.50. Once we fully have defined the feature, we can hit check mark and check mark, and then it brings us out to our model where we've created every feature on the part except for the chamfer. So I would hit save. At this point, let's go back to our drawing and see what size our chamfer needs to be. Well, the chamfers are 10 thou by 45 degrees unless otherwise specified. So when I look at my drawing, I realize that I have a chamfer call out right here, other than what's specified. So the bottom edge gets a 25 thou chamfer, while the rest of the chamfers on the top edge are 10 thou. So let's apply that in our model. Moving over to our model, the chamfer features underneath fillet. So when I hit chamfer, I move to the back side, and I type in 0.025 inches. I click on the bottom edge, and if full preview is selected, it shows you a preview of your chamfer. I hit check mark, and that creates the bottom chamfer. If I'm going to create another chamfer, they're both going to say chamfer, chamfer 1 and chamfer 2. So what I like to do is hit feature properties and write bottom chamfer. Now, I'm going to go ahead and select chamfer again and select 10 thou. Realize you can chamfer an edge or a face. If I pick this whole face right here, it chamfers the inside and the outside edges. Notice, I don't always want to chamfer every edge. So right now, I'm going to work myself around the outside here. I'm not going to chamfer my counterbore or my countersunk hole, but I am going to chamfer that one on both the top and the bottom. Actually, I'm going to pick just the top edge. I'll chamfer that one. Chamfer that one. We're not going to chamfer this edge. It's too hard to get with our tool. We'll let you break the edges after you machine it on the CNC mill. But we will chamfer these bottom ones. Bam. And that one. Once I've selected all my edges I would like a chamfer on, I hit check mark, I press space bar, isometric, and I hit save. And that completes my entire solid model for mill project number 1. Not too bad, 38 minutes. You can easily do this. Now, we're going to move on to the engineering drawing in part 2. I look forward to seeing you in that video.